Hi, we meet again on Chapter 8, Form 4, KSSM, Respiratory System in Humans and Animals. And this is the second video for 8.1, Types of Respiratory Systems. The content standard for today's lesson is 8.1, Types of Respiratory System. The learning standard 8.1.1, Identify respiratory structures in frog, and the second one in human. 8.1.2 Describe the adaptation of respiratory structure and their functions for gaseous exchange in animals and humans. So for animals today, we will concentrate on frog. Next one, 8.1.3 Compare and contrast respiratory structures in humans and animals. The success criteria for today's lesson. The first one, identify respiratory structure in frog and describe its adaptation. The second one, identify respiratory structure in humans and describe its adaptation. And the third one, compare and contrast respiratory structures in humans and animals. The respiratory structure for frogs can be divided into two, meaning frog can respirate through two respiratory structure, that is through skin as well as lung. So we are going to see the adaptation for frog skin first. Frog skin is thin and highly permeable. When it is thin, it is easy for the gases to diffuse. The next one, frog skin is moist. This allows the gases to dissolve easily. Next one, underneath the skin of the frog, there are many networks of blood capillaries. So these blood capillaries will make the transport of respiratory gases faster. Next one, we look at the lung of the frog. The picture at the back shows the lung of the frog. So you can see that the lung of the frog is folded. Okay, this is to increase the surface area of the lung so that more respiratory gases can diffuse. The next one, the lung membrane is thin. Again, when it is thin, it is easier for the respiratory gases to diffuse. Next is moist. The lung wall of the frog is moist so that the respiratory gases can easily dissolve. And the last one, the lung of the frog is rich with network of blood capillaries. Again, it is to make the transportation of respiratory gases easier. Now we look at the human respiratory structure and its adaptation. Human respiratory structure is alveolus, that is at our lung. So the adaptation for alveolus is there are a large number of alveolus. You can see the picture here. This is the picture of alveolus. There are a large number of alveolus. This one, the large number of alveolus is to increase the surface area so that more respiratory gases can diffuse. The next one, the wall of the alveolus is moist. Again, moist is to ensure that the respiratory gases can easily dissolve. Next, alveolus is surrounded by a rich network of blood capillaries. You can see this one, the blue and the red color are all the blood capillaries. This is to ensure that the respiratory gases can be transported easily. And the last one, the thin wall of alveolus. This one again to ensure that the respiratory gases can diffuse easily because the wall is only one cell thick. Now after we have learned the respiratory structure for insect, for frog, for human and for fish, we want to compare their respiratory structure. So in this slide, we are going to see the similarities of these animals with humans. Okay, so this one is the similarities. Okay, we look at the first similarity. All the respiratory structure that we have learned have a large ratio of total surface area to volume, TSA over V ratio. Why? This is to ensure an efficient exchange of the respiratory gases. The second similarity is all the respiratory structure are thin. This is to make sure that the diffusion of respiratory gases is easier and faster. And the third similarity, all the respiratory structure are moist. This allows the respiratory gases to dissolve in them. And the last one, the respiratory structure is complete with rich network of blood capillaries except for insects. This allows for efficient transport of respiratory gases. Now, we look at the differences between the respiratory structure of human with the animals that we have just learned. So, we look at the respiratory structure for each of the animals and human because their respiratory structure is different. For insect, the respiratory structure is tracheal. For fish, the respiratory structure are filament and lamella. For frogs, the respiratory structure are skin and lung. And for human, the respiratory structure are the alveolus. And how this respiratory structure can achieve TSA, total surface area over volume ratio increase. So for insect, there are a large number of tracheoles. For fish, there are a large number of filament and lamella. For frogs, the surface of the lung is folded and the overall skin surface is also folded. And for humans, there are a large number of alveoli. So all these adaptation ensure that TSA over V is high or is large. We have come to the end of 8.1, that is the respiratory system in humans and animals. So if you want to take the quiz for the second part, don't forget to click the link down there and also subscribe my channel. See you next time. Bye-bye.